Okay, so topic of the day is linear equations in one variable. Let's start by defining them. So linear, so we call them linear or first degree. That means the same thing. First degree linear. We're going to see why we call them that.
Professor, I'm sorry. What's the word number one?
Here definition: linear or first degree equation. Okay. Right. So last time we saw expressions which are basically numbers and letters. Numbers and letters make expressions. For example, x plus 2, x plus 2. So that's an expression with numbers and letters. To make it an equation, it needs an equal sign. So once you add an equal sign to this expression, equal to something else, some statement here, maybe 5. So that makes an equation because it has an equal sign. That's all. That's basically how easy it is to identify an equation. And each equation has a variable or more. Variable or unknown. Could be just one x, or could be x, y, z, but we're only going to see equations with one variable today. And that variable, could call it x, we can call it a, n, whatever it is. Usually it's an unknown number that we don't know, and we try to find the value of. So this is a very simple equation. So basically, this is a statement that says a number added to 2 is 5. What's that number? Obviously, the number is x is equal to 3, right? So basically, that's the solution to this equation. Because if you put 3 here, if you check it, you put 3 into the equation. So basically, it's 3 plus 2, and you say, is that equal to 5? Okay, when you plug it, you should make the two sides equal. So if you say the solution is 3, you plug it in, replace the x with the solution, then you simplify, and that works. If you say the solution, for example, is 4, that would be wrong, because if you put 4 here, it would be 4 plus 2, which is 6, would be not equal to 5, and 4 will not be a solution. But this one is a solution. So 3 is a solution to this equation. The only solution is only one number to that equation. So that's a very simple example of an equation with one variable. And the reason why we call it linear or first degree is because of the power of the variable or the unknown, the power of the x. That's the reason why we call it linear. It's because of power 1. We call it linear or first degree because of this. If the power is different, the power could be 2, could be 3, could be 4. It would be a different type of equation. We're going to see later this semester how to solve equation with power 2, power 3. Call this quadratic, cubic equations. But today, only going to talk about first degree. Okay, 1 degree, 1 variable, just x, and the power is 1. So that's basically what first degree equations are. The standard form, generally speaking, they all look something like this. Standard or general form is this. They all basically look like this. You have x to the power 1 and some numbers here, for example, 2 and 5. There might be a number here. It could be a number, for example, 3 here or something, or -3. So there's always a number here, some number here and a number here, real numbers. Could be fractions, decimals, could be whole integers, whatever. And you have x, and it has to be to the first power, unless otherwise you will not be a linear or first degree. Okay, so all of these look in this form. Let me give you a few examples. So this one, or maybe, like I said, 3x minus 6 equals 12. That's also in this form. As you can see, A is 3 here, B is -6, C is 12. Well, the only thing that changes basically out of these numbers, A, B, C, and the x is always there. So it could be like this, or you may have some parentheses like so. For example, this. Okay, so once we simplify these, they would look like this. You might be even longer than this. For example, something like this, negative maybe 5, possibly 2x plus 1, maybe plus 11x equals 4. Okay, maybe it'll be like that, longer equation. But this, again, if we simplify it, it will look like this. I'm going to see how to do that in a moment. So take these, simplify them, it'll look like that. You may also have an equation that looks like this, with x on both sides, not just on one side. As you can see, we have x here and x here on both sides of the equal sign. We'll see how to solve that as well. These are just different forms, but again, they all should look like this. Once we simplify them, you'll see that they all look like the standard form. The general form is that. Okay, we're going to see how to do that in a moment. Could be like this, this. You may also have a fraction. Okay, equations could have fractions. For example, x over 3 equals 6. As you can see, we have one fraction. There could be two fractions in one equation, maybe something like this. Again, like I said, these numbers A, B, and C, they could be whole numbers, integers, they could be fractions, they could be decimals, they could be all sorts of numbers because they're basically real numbers. Okay, you could have one fraction, you could have two, maybe even three. For example, this. It's also possible. And maybe 1 over 6. Okay, so we're going to see how to solve all of these. All of these. We're going to see how to solve each one of them. And again, they all basically, whether you see it or not, they're practically in this standard form. You'll see that when we simplify them, they all turn into something like this. They're all going to look like that. Even that one, this one, when we simplify them, we're going to make them look like this. All right, so that's just the definition of the introduction. Let's get to the actual solving of these equations. Any questions so far, everybody, before we move on to solving?
No, perfect.
Okay, everybody else, any questions? Please feel free to ask if you have any questions at any moment. Feel free to jump in.
Professor, good morning. This is Dahin Suggestion. I'm using my phone. So to let you know that I'm here, okay?
Okay.
All right.
All right, so so let's see how to solve these. Starting with the first one, maybe let's do this one. No, it's simple, but it has one step. Let's see that step. So basically, so the first one, we said x is 3. This is how you actually do it. So basically what we do here is we just cancel the positive 2 to get the x by itself. So when you solve, you want to get the x by itself equals some number. So here we have x plus 2 equals 5. You want to isolate this. You want to get it by itself equals something. How do we get rid of this positive 2 to get the x by itself?
-2.
By subtracting. That's right, we do that by subtracting. So we cancel this. So we can do -2 on both sides. Because it's an equation, whatever you do here, you need to do on the other side. So we need to cancel positive 2. That's why we subtract it. That cancels. But again, it's equal. You have to keep everything balanced. So if you subtract 2 from here, you got to subtract 2 from here. So 5 take away 2 is 3. That's why we said 3 here earlier, but that's the actual step we do to solve that equation. So that's one solution. Again, you can check it. If you plug it, it would be 3 plus 2 equals 5, and that works. So that's basically one step. We call this a one-step equation. Okay, one-step equation. The longer the equation is, the more step it will take. So this was probably the simplest one. Let's say this one here. Probably going to take more steps. So again, the purpose of this is to isolate, to get the x by itself. and find the value of it. So which numbers or what numbers need to be canceled here in order to get the x by itself?
6.
That's right, the -6 should cancel. Okay, what else? What other number do we need to cancel besides the 6?
3.
That's right, to isolate the x. So we're going to cancel this and cancel this. So we don't worry about 12, it's on the other side, not a problem. So let's cancel the -6. So by doing the opposite, this is the inverse property we saw last time. The number and its opposite cancel out. So if you add 6 here, you got to do the exact same thing on the other side. Add the same thing because it's an equation. You want to change. You don't want to change the equality. So 3x. These cancel. 12 plus 6. That's 18. Now we just need to get rid of the 3. How do we cancel the 3 here to get the x by itself?
We divide 18 by 3.
We divide 18 by 3. That's right. So
Yeah.
divide by 3. Divide by 3. So we get 6. And that's basically those two steps to solve this equation. It's pretty simple. You can always check it. You can always check the solution. So to check the solution, all you have to do is plug the x into the equation. So you take the very first equation and you plug the 6 into it, the possible solution, because this could be wrong. So we're going to plug the 6 here. So it's going to be 3 times, instead of x, we're going to put the 6, which is here, minus 6 equals 12. And we say, we don't know it yet, actually. We need to say, is it equal to 12? So 3x minus 6. So instead of x, we put the solution, the possible solution, and we say, is it equal to? So we don't know yet, that's why we're checking. Then you simplify this. So do the multiplication first, that's 18 minus 6, and we say, is it equal to 12? Then simplify more. So 18 take away 6, that's 12 and 12. So that's good. So if you get 2 equal sides at the end, that's how we know your solution works. So no problem here. But for some reason, if you get something that's not right, for example, 7 equals 3, of course, that's wrong. That means there's a problem somewhere. So if you don't get 2 equal sides, first double check this. If you don't find a mistake here, then you go back, check your steps here, check the signs. A lot of times, a lot of sign mistake could occur and make everything wrong. So carefully check your steps and check your signs if something is not right when you check your solution. Okay, so that's a 2-step. This one took 2 steps to solve, so we'll call it 2-step. 2-step equation. Okay, any questions, everybody, about these 2 problems before we move on to another one?
No.
Everybody, please let me know again at any time if you have any questions here.
No, I'm good.
Okay. Now let's say this one here. This one with the parentheses. Let's see how to solve that. Basically, 2x plus 4 equals 8. So just like we did last time when you have an expression with the parentheses. So what's the first thing we do here in order to solve this or simplify it?
We
You multiply.
multiplicate.
You multiply, like
That's
you
right.
multiply 2 by x plus, it's gonna be like 8 plus 8 equal 8.
That's right. What do we call that property again? What do we called it last time?
Distribute.
The distributive property. That's right. So whenever you have equations in a when you have parentheses in an equation, first see if you can add anything inside, if possible. If not, then you go to the distributive property. So 2 times x, that's 2x. And 2 times 4, that's 8. And we have 8 here. Once we distribute, now it looks like this. So we have something in this form. And again, like I told you, when you simplify any of these equations, once you simplify any of these, they all look something like this. They all look like this, the standard form. As you can see, that one also looks in standard form or something like this. So we're going to repeat the same two steps again. So what's the first, what's the next step here to isolate x?
You're gonna okay, you're gonna say 2x equal 8 minus 8 because you're gonna transfer the 8 onto the other side.
Okay, so we need to cancel this 8 and then cancel the 2. So to cancel the positive 8, we just combine it with the opposite. So the opposite is negative 8. Do the same thing on the other side. Again, these two cancel out as we saw last time. The inverse property. Bring the 2x down, the equal sign, and 0.
X equal to
one more step. One more step. We're going to divide by
2.
That's right. Divided by 2 here, by 2. So the 2's cancel out. Basically, we have a multiplication here. 2x means 2 times x. So the opposite of multiplication is division. The opposite of addition is subtraction. That's why we cancel these. Here, we have a multiplication. So to cancel the 2, we divide by 2. So x is 0. So that's it. That's the solution. Again, you can always plug it and, use the order of operations. Make sure your solution works. If not, again, most likely would be a sign mistake, or sometimes instead of adding, you subtract or something like that. But usually just some sign mistake that makes the answer wrong. Okay, so that took 3 steps. Distribute, cancel 8, cancel 2. As I said, the longer the equation, the more steps. Not necessarily the more difficulty, just more steps, but that's about it. Next one, we have a longer equation here. Okay, so let's see how to solve this equation. So a bit longer than this, so let's write it down first. All right, so what else again do we do first here? To solve or
multiply. You solve the parentheses.
That's right. So always distribute first. So it's not this first. Okay?
Yeah.
It's not subtraction first, because when you do the order of operations, addition and subtractions come last. So do not do this first. Just because it appears first doesn't mean it has to be done first. So distribute the parentheses first, or maybe add any like terms if you have any like terms inside. So distribute that. The 10 stays the same. Bring this, the 10 down. Now we're going to distribute with this number with the sign. So -5 times.
Okay, negative 10x.
That's right. That would be -10x.
Negative 5.
Exactly. -5 times positive 5. So make sure when you multiply with the sign next to the number. That sign multiplies whatever signs you have inside the parentheses. So that's -5 plus 11x equals 4. Okay, so we distributed. What else will we do now?
Put the numbers in one side and the number with x in the other side.
Before that step, that would be the next one. Before that, we are still on the same side. So we have the equal sign, we're on the same side here. What do we do on the same side?
Similar elements.
That's right, combine like terms. So we're not moving things around yet. Let's simplify the side first. So we have basically these two together are like terms.
11x equals
Okay.
1x.
That's right. So we have 10 and -5. So it would be 5. Then you have 10 plus -10 plus 11. -10 plus 11 would be plus, that's right, 1x. So basically we are still on the same side. So we're not moving to the other side yet. We're still on the same side. We're just combining like terms. So basically distribute. Distribute basically is a multiplication. Here we combine combine like terms, that's basically adding and subtracting like terms. So we simplified, so we have 4 here. So as I said before, once you simplify the equation, it looks in standard form. So now it kind of looks like this. In 1 or 2 steps, it went down from this long equation to something simple. That's
That's gonna
basically,
be x. It's gonna be x equal 4 minus 5.
that's
X
right. So
equal
basically,
minus 1.
that's right. So we need to cancel the 5. So 1x is basically x. So we need to cancel the 5. So we subtract it, or do you move it to the other side?
No, the
So
side,
this
yeah.
is, that's right. This is the part where you move x's to one side and numbers to the other. But since we have x on one side already, let's cancel this 5 by the opposite. It's a positive 5. So minus 5 on both sides, cancel those. X is negative 1. So as you can see, even though it was a long equation, it took about, what, 3 steps? 1, 2, 3. So 3 steps to solve this long equation. So we distribute it first, combine like terms, and then basically we isolate the x at the end. Okay, so that's basically how you solve equations. I mean, even if they're long, that doesn't mean they're complex, but be careful with your signs and the properties. The properties we'll learn last time of real numbers, especially the distributive property and the commutative property. This is the commutative property. That's when you move things around to combine them together. So that's the commutative property. And after that, you use what we call the properties of equations. You know, when you subtract from both sides, for example, we call that the subtraction property. Subtraction property of equations. When you add something to both sides, we call that the addition property. When you divide, like we did here, both sides, we call that the division property of equations, and so on. So we use those properties along with these properties of distributive property, commutative property. We apply that to these equations. Okay, everybody, any questions here?
Excuse me, what the last
Isolate,
operation name? Yes, that one.
isolate x. All right, so any other questions, everybody here, before we move on to something else? Everybody, so let's see. We have one more here before we go to the fractions. Let's see that one here. This one happens to have, as you can see, variables on both sides. It's 4x minus 3. So 4x minus 3 and 3x plus 2. So the only difference between this and the previous ones is this one has x on both sides, not just on this side like with these equations. So what you want to do here is, usually we try to keep the x on the left side. It doesn't matter where you put it, but most of the time it's going to end up on the left side like this. But it's not I mean, something you have to do. As long as you keep the x on one side, the numbers on the other, that's good. So 4x minus 3 equals 3x plus 2. So what you want to do here is you want to move first. If you have any in a parentheses here, if you have anything to combine, do it first. Basically, if you have something like this on this side, do this first if possible. These 2 first steps. We don't have any parentheses. We don't have any like terms. So what we're going to do is we're going to move this over. We're going to move the 3x across the equal sign to this number. And then we're going to move that number also back here to combine it with this. Basically, we're moving things around so we can combine like terms. Okay, so they're on different sides, so we can't just add them or subtract them right away. We have to move them first. And when we move them, so we have 4x that stays here. And we're moving this next to it. So if you move something across the equal sign, we change the sign. So 3x moves over, becomes negative 3x, because it's positive here, becomes negative on the other side. And then we have plus 2 on this side, it stays the same. This negative 3 It's going to move to the other side of the equal sign. What's going to happen to it if we move it to the other side?
Positive.
Positive 3.
Right, the
Become
sign
positive.
changes.
Positive
That's
3.
That's right. The sign changes from negative to positive. Only if you move something to the other side of the equal sign. That's when you change the sign. If you, here, we didn't change the sign because we are on the same side. Okay, we have the equal sign. Here, we just combine them right away. Plus, minus 10, plus 11, 10, minus 5. We combine them right away. We did not change the sign. For example, we kind of moved this over. We didn't write the step, but we moved it over to combine it with this. We didn't change the sign, just combine them right away because we are on the same side. Only if you move something from one side of the equal sign to the other, that's when you have to change the sign. So now that we have them on the same side, we can go ahead and combine them. 4x, take away 3x, that's of course 1x. And we have 5 on the other side. So 1x is the same as x. No need to divide or do anything here, unless you have some other number, unless you have -1 or 2 or something else. So the solution here is 5. Okay, so that's important if you have x's on both sides. First, again, simplify each side. Work on each side first, simplify it as much as possible. And at the end, if you still have x's on both sides, move them, move the x's to one side, the numbers to the other, and then isolate the x. So that's important. Let's do something else like this, but maybe with more terms here, parentheses. For example, you may have, let's say 3 plus 2x, it might be 5x minus 1. Maybe minus 4x. And the other side, something like this also on the other side, maybe 7 minus, and possibly 3x plus 4. Basically something like this. And we'll see if we can simplify it. So this is probably the longest one you'll see today. We have equal sign, we have a whole expression here. We have a whole expression on the other side. And the purpose again is to get the x by itself. Only x by itself equals some number. So what is it that we need to do first here in this equation? What's the very first thing?
You do the same thing, distribute.
Okay,
X,
that's right. So
the
basically,
parentheses.
that's right. So basically what we did here earlier to this side, we're going to do it again. This time we're going to do it to this side and also this side, because this side needs to be simplified. Because we have not just one number here, we have a whole expression. So we're going to basically do this on both sides. So if you want to write the steps, we say, so distribute again, combine like terms. So it's going to be 3 plus 10x minus 2 minus 4x. And the same thing on this side. So 7. What else? How do we distribute this part here? So we do this.
The sign. You multiply the sign
That's right. So we're going to distribute the minus here.
to the parentheses. Yeah, parentheses.
That's right. And here. So basically we're going to do 7 minus times a
So it's
minus.
gonna be 7 plus 3x minus 4.
That's right. And negative times positive would be -4. So basically we're doing this on both sides, each side by itself. So simplify.
And you're gonna combine it.
That's right. So basically what we're doing is, so simplify each side first. And that includes combine, basically distribute. Okay, distribute and combine just like this. That's the first step. So let's finish that step first. Let's combine like terms. So we're combining these two with these two. Also on the other side, you can combine these two numbers. So 3, take away 2, that's 1.
It's
Yeah,
gonna be
positive 10.
1 plus 6x.
That's right. We have positive 10 minus 4. So those we combine. We don't have to change the sign. Again, we're not moving to the other side yet. We're still on the same side. We just combine them right away. Plus 10 minus 4, that's plus 6x.
So, Professor, is it possible that I will move
Equal
the
3,
numbers?
3 plus 3x.
Go ahead with the
I have a
question.
question, please. Yeah.
Sure.
Is it possible that I can move the numbers next to each other without x, then the numbers with x next to each other, so it will be easy for me in the operation? So
You
like-
want to write them next to each other first?
Yes,
10x.
yes.
Okay,
Yes, is
you
it
can
possible
do
that
that.
I do that?
Yeah, you can do that. For example, so you want to take this, move this next to it. You can do that first if you want, but don't change the sign if you move.
No.
Okay, it's the same side. Only if you move, for example, this one here, that's when you change the sign. Okay, you can do that first. You can put them next to each other like this, and then combine them. That's fine. Okay, so basically we combined these two together, and here we combined 7 and -4. So this is 7 and -4 is 3. Bring it down to positive 3. And as you can see now, this kind of looks like that. So basically we have this side completely simplified. So what is the next step now based on this problem?
1 minus 3.
So we need to move. That's
The
right, we're
other
going to move.
side.
That's right, move x's to one side. And the numbers to the other. Okay, so once you get to this point, again, make sure you simplify each side first before you start moving things around. So we're going to move the 3x next to 6x, and all at the same time, we're going to move the 1 back here next to 3, so we can combine them together. So 6x here. Again, what happens to positive 3x if we move it to the other side of the equal sign? What happens to this? Positive 3, when you move it over, becomes?
I mean 6x minus 3x.
That's right. So this positive 3x becomes negative 3x.
And
And-
3 minus 1.
That's right. So this 3 stays the same. This positive 1 here has an invisible plus here. You're going to move
Yeah,
it back.
because of the sign, you move it. It's gonna be opposite sign.
That's right. And finally, so now that we have them together, we can
3x
combine
equal
them.
to
That's right. 6 minus 3, that's
3x.
3. And
2.
2.
So you're gonna simplify 3 is gonna be like x equal 2/3.
That's right. So we're going to divide by 3. So the last step is to cancel 3. So we're going to divide by 3. Divided by 3. X is 2/3. If you have a fraction, reduce it if possible. It is okay. If the x is a real number, that means it could be fraction, decimal, negative, positive. It could be any type of number. So it's okay to have a negative, a decimal here. Just make sure you reduce that decimal. You reduce that fraction whenever possible. If you can reduce it, that's fine. Just leave it like that.
So, Professor, can I have a question? All x on the left side, right? It's a rule.
You could actually put it on the right side also if you. Sometimes it's more convenient to move it to the left side. That's fine. To the right side, that's fine. And you move the numbers to the other. Either way would be fine. Okay, so
Okay.
it shouldn't be a problem. Okay, so as you can see, this is the longest you can get. So
I don't think
maybe
I have that reflex though.
I'm sorry. Did
I
you have?
don't think I have that reflex.
I couldn't hear you. Say it again. I'm sorry.
Oh, I'm sorry, Professor. I'm sorry.
Are you talking to us or? Okay. Okay, like I was saying, so this is probably the longest one. It took 1 step, 2, 3, and 4. So this whole thing took 4 main steps. So basically we simplify it first, work on each side, distribute and everything, do this. And then the other step was to move, once you simplify, we moved the x's to one side and numbers to the other. And you may add another step here, 3. After you move things around, so you need to isolate the x. Simplify or isolate the x at the end. After you move, so simplify and isolate. So it doesn't matter how long the equation is. It's going to involve these 3 steps. Doesn't matter how long it is, you go by these 3 steps. And every time you'll get your solution. Again, a lot of it is basically adding and subtracting. So those are the properties we learned last time. And at the end, again, after these 3 or 4 steps, you'll get your solution. You can always plug it. Okay, you can always check it here, do all the math here and simplify and so on. Okay, so that's basically how you solve equations, and these steps always work. Now, so far we didn't see any fractions in the equations. So let's see how to solve equations with the fractions now. We're gonna do this part. Okay, there could be 1 fraction, 2 or more. It's a little different. So before we do all of this, before we do these steps, basically we try to cancel the fractions. Once we cancel them, the equations will become much simpler. They can become just like these here after we cancel the fractions. So let's look at those. So equations. Equations of the fractions. So the first example, I believe, was x over 3 equals 6. That's one equation. Again, we just want to get the x by itself. So we need to cancel the 3 here to basically isolate or get the x by itself. How do you cancel this 3 here from this fraction?
Multiply by 3.
That's right. So we have this 3, we have a division. So the opposite of division is multiplication. Earlier here, you see how we had 3x, we divided. Now it's the opposite. We have division, we need to multiply both sides by 3 to cancel 3. So let me just write the equation again. So I'm going to write it again. It's x over 3. So again, to cancel the 3 here, we just have to multiply by 3. That way, the 3 and 3 cancel out. And if you multiply here by 3, make sure you do the same thing on the other side. You're going to have to multiply, that's right, by 3 as well. So we're going to end up with x equals 18. So basically, just like here we did the multiplication property. This is what we call the multiplication property of equations, which basically means multiplying both sides. Because we had a division, the opposite of division is multiplication. If you have addition, you subtract. If you have subtraction, you add. Basically, you do the opposite, so you can cancel whatever number you need to cancel. That's the case with 1 fraction. Sometimes you may have, well, there's another way, actually, another way of doing this. This is one way, and we have a second way. So basically, you take your...
We simply multiplicate 6 with 3.
Multiply, that's right, 6 by 3. So what you do is you take the equation, you make 2 fractions out of it. This one is already a fraction. You make that one a fraction as well. And then we just cross multiply. Instead of multiplying both sides by this denominator, here, we're going to cross multiply.
Cross multiply.
That's right. And the fractions will go away. So we're going to do x times 1 and 3 times 6.
18. Yeah.
Okay, so we're going to cross multiply x times 1 is x. And again, 3 times 6 would be 18. As you can see, we get the same answer here. Here we use the multiplication property, but here we cross multiply it. So cross multiply. Cross multiply, that's how we got this. So you can do it in either way, that's fine. If you have one fraction only, you can use this, you can use cross multiplication. But if you have two fractions, the easiest way is to probably cross multiply. If you have, for example, -2, let's say 1/3 here, maybe 5 on this side. So if you have two fractions, just cross multiply them right away. That's probably the easiest or the fastest way. Cross multiply them to cancel the fraction. They will cancel it right away. So multiply this way. And also multiply the other way, just like we did here. So basically we'll multiply these two and these two. We call it cross multiply, cross multiply. So -2x times 3, that's -6x. 5 times 1, that's 5. As you can see, once you cross multiply, the equation becomes simpler, like we saw previously, and we just need one more step here and we solve it. What is the one next and last step here to solve this? What do we do here now to solve this?
To move the -6 to the other side, so we have a factor.
Okay, well, basically we need to cancel, that's right, we need to cancel the -6. Move it or divide by it. So we can divide to cancel -6. We're going to divide it by itself. Just like we did here earlier with, for example, here we had 3x. We divide by 3 on both sides. Same thing here, we have -6. We want to cancel it, so we divide it by itself. It cancels. We're going to end up with x by itself. And also divide the other side by -6. Divide by -6, divide by -6. So 5 by -6. Or we can write it like negative first and 5/6. So, so once you cancel the fractions, we apply these steps again. So simplify if you have to simplify in parentheses. Move the x's if you have to move, and then isolate the x. In this case, we just had to basically do the last step here. After cross multiplying, we just had to isolate x by dividing. And that's our solution. Reduce it again whenever possible. Try to reduce your fraction. If not, that's fine. So the answer could be any sort of real number, decimals, fractions, negatives, everything, like I said before.
Professor, could you please explain the last step?
So first we cross multiplied. The -2x times 3 is -6x. 5 times 1 is 5. Then we needed to cancel the -6. So to cancel this number, to isolate the x, we divide it by itself. So -6 divided by -6. But make sure you do the same thing on the other side. If you divide here by -6, you also divide the other side by -6.
Okay.
Just like we did here. Just like, for example, if you have 2x equals 8. So you divide by 2, divide by 2. X is 4. If you have a negative here, you divide by negative. So you divide the number by itself. To cancel it, you divide that number by itself. And if you had a negative here, you would divide by -2. It would be 8 divided -2, which would be negative. Okay, so that's basically what we did in this problem.
But you had 5 minus 6, 5 negative 6. How it appears to -5, 6?
I'm sorry, can you repeat that question?
So it turns out it's x 5 to minus 6. So I mean, how minus moved to 5?
Okay, so what do you mean? So when you have a fraction, when you have a minus, you could put the minus in the middle. you could put it up here or down here. It doesn't matter where you put it, it will be the same value.
Oh, really?
Okay, so whenever you have a minus in a fraction, you can put it anywhere, up, down, or usually in the middle. It's better to put it here in the middle like I did here. So it was down here, I moved it up in the middle, but
Okay.
it's still the same value, okay?
I didn't know that. Thanks.
Okay, all right. Okay, so that's basically what you do if you have two fractions only, cross multiply. Now let's see what happens if you have multiple fractions. See here, we have a bunch of fractions. So let's see how to solve this problem. Let's see how to basically get rid of all these fractions at the same time. Okay, so we have three fractions. So apparently, you can't just cross multiply because cross multiplying works if you have only two fractions, one on each side. One on each side, you can easily cross multiply. So here we have a bunch of fractions. What do you guys think? How do you, there's at least
We put
three
them
ways.
under the common denominator.
That's one way, that's right. So one way is to find the common denominator.
Yeah, which is
There
12
are
in
at least
this case.
That's right. And there's at least a couple more ways. Can anybody think of another way, different way to do this other than the LCD? Other than the common denominator? What do you think? Any other suggestions, any other methods you might think of? There's at least another two in addition to the common denominator. What do you think?
No, never mind.
So if
We multiply by 12.
okay, so that's one
and we
way.
cancel
So
them.
if we try to do the same steps as before, you might be thinking we could move the number here, move the x's to one side, the x's here, move the number here. Or you may say also we can add these two together to make them one fraction, and then we'll end up with something like this. Make these one fraction, then cross multiply. That's another way. But probably the easiest, you can use any way, by the way, you can use any way you want, whatever you're familiar with, that's fine. But one way that I find probably easier than the others and quicker to cancel all these fractions, we find the least common denominator. Just like when you add fractions, you need to find the least common denominator. That's what we're going to do here. What is the least common denominator here? Or the LCD? We also call it the LCD.
12.
It's not 12.
9.
It's not 9. LCD for all these. The number, the common multiple that all of these can go into. What is it?
I think 36 or something.
36 is not. It is, but it's not the
18.
least. 18 is the least.
18.
That's right. So the least. Okay, so remember when you add your fractions, you need to have the same denominator. You find the least or the smallest one. So the least here is 18. So the least or the smallest multiple, if you do 3, 6, 9, 12, and so on, then you do 9, 18, and so on, 6, 12, 18. The common multiple would be 18. If you have issues with the fractions or finding the LCD, there is a link next to homework 1. Okay, you can review that. It has from a previous class, a lower class, you guys can review fractions. Link on Blackboard. Next to homework 1. This explains to you the fractions and how to find the LCD. Okay, explains all about the fractions, especially finding the LCD, because that's important when you find the LCD. It's important to solving equations. So let me write the equation again. So the first step, you find the least common denominator for all the fractions. If you have more than 2, if you have 2 only, it's easier. cross multiply. If you have 3 or 4
Oh,
or
the
5 or
second
more,
denominator is 9, not 4.
no, this is 9.
Oh, yeah.
Okay, that's 9.
That's why it is 18.
Why,
Alright,
but why this couldn't be 3, for example?
What it could be? What? Sorry.
3. Why it couldn't be 3?
No, it's a common multiple. All of these should go into it. All of these should go into it. Not a common factor, a common multiple. You're thinking about a common factor, 3 here and 3 and 3. But that's not what we're looking for. We're looking for the common denominator. Also a common, it's called a common multiple. Okay, so it's different.
Some number that we could divide all these numbers, right?
The number that, yes, can be divided by all of these, or all these can go into. So again, everybody watch this. If you have review your fractions with, there's a link, I put it there from my other classes, Math 2 class. So we will explain everything about the LCDs, like a long lecture on all the fractions and everything. So review that, it should help. If not, let me know next class. Okay, so that's the first step. You want to find LCD. The next step, once you find LCD, you just multiply all by LCD. You're going to find LCD, which is 18. Next step is pretty simple. Just take that LCD, just write it next to each fraction as a multiplication, okay? As a multiplication, but we're not multiplying yet. So we're not multiplying yet. Instead, we're going to divide all of these so we can cancel the fractions. So see what happens here if we simplify or divide. So 18, we reduce it by 3, you get 6. Bring down the x, then plus. Then again, before doing the multiplication, reduce first. With multiplication of fractions, we always reduce before multiplying. Again, you'll see that in this link about review of fractions. Times, so 18 by 9 is 2. So this 2 is here, reduced 18 by 9, that's 2. What else? What happens to the third one?
Divide 18 by 6.
Okay, that's right. So it would be 1 times
3.
times 3. That's right. So that's basically how useful it is to use the LCD. So all the fractions are gone now. So we had a bunch of fractions, they're all gone. The rest is pretty simple. This is the standard form. If you remember, that's the standard form, 6x plus 4 equals 3. But again, looks like this, standard form or something like this. So all of these basically, once you simplify them or cancel the fraction, they look like that. So this, basically we turn it into this. And the rest should be pretty simple. So now we can multiply 6x plus 4 equals 3. Okay, the other steps we know what to do now. Subtract 6x equals -1. Finally, divide by 6. X is -1 by 6. So the important part was this. This we've done earlier. The important part is basically canceling all the fractions using the common denominator. That's the important part. So find LCD, we did. Multiply all by the LCD. Just put the LCD next to each fraction. And third step, basically reduce the fractions. Reduce, cancel the fractions, and you end up with a much simpler equation. Once you cancel the fractions, we're back to all these steps again. Okay, so cancel all your fractions, and you apply those steps. If you have parentheses, do the distribute first, combine like terms, move x and y and numbers, and so on, just like we did. Okay, so this works even if you have, let's say, 6 fractions or 7 fractions in one equation. It works the same way. We cancel them all at the same time, all at once. Again, that's probably the easiest method, the quickest one. If you want to use another method, that's fine. I'm sure some of you have other methods. You may want to add these, you want to move this over, whatever you want to do, that's fine. Just you can use your method, but check this out. This is probably the fastest way because in one step, the equation goes from 3 fractions down to some simple, standard form equation. Okay, everybody, does that make sense here about this equation?
Yep.
Okay, everybody else, any issues with this problem?
No purpose.
It should be pretty simple, okay? Again, though the important part here is to know how to find LCD. If you're having troubles with it, again, just review your fractions any way you want, or again, check out the homework, although there's a link for you, because I know some people can forget their fractions, so I included that link there for you to review. Let me give you another one. Let's do another one like this one here. We're going to repeat almost the exact same step. So check this out, everybody. Let's say we have maybe 2x over maybe 3 minus probably 1/4, and on the other side maybe 5/6. Let's even put an x here. So multiple fractions here. Again, we can't cross multiply. Cross multiplying works only if you have 2 fractions like this, or if you have 1 fraction. So what can we do here first to solve this equation?
Find the LCD.
Find LCD. That's one way, probably the quickest way. Again, if you're thinking about something else, maybe you want to move x here, move 1/4 here, add these two together, then cross multiply. Sounds like a lot of steps. You can do that still, but maybe it's easier to find the LCD. You have 3, 4, and 6. What's the LCD for those?
12.
12. That's right. Basically, it's a common multiple. If you do 3 plus 3 plus 3 plus 3, you'll end up with a 12 somewhere. If you do 4 plus 4 plus 4 would be 12. 6 plus 6 would be 12. So it's a common multiple or a common denominator. Okay, that's the first step. Let me rewrite it again here. What do you do after finding LCD?
Multiply.
That's right. So just like here, you find that LCD. All you have to do is just write it, multiply it by all the fractions. But you're not actually multiplying yet. Don't do the multiplication yet. We'll leave that for later. It's like here. Okay, we found LCD, multiply. What else?
Divide.
That's right. Divide, simplify, reduce, whatever you want to call it. Divide, or also you can say reduce or simplify. Again, those are the main steps every time, just like here. So what do we get from the first? What do we get from this one?
4 multiple 2x.
That's right. So we reduce. That's what we mean by divide. So we don't multiply yet. So 12 divided by 3, that would be 4 here, times. You bring this number down. Whatever this is, you bring it down. We're going to multiply in the next step. Don't try to do all at once. Step by step. What about this one here?
3
1 times.
minus 3.
That's right. 12 divided by 4. It's 3. And the last one again. Do not multiply yet. What are we doing instead?
5x multiplied to.
That's right. So 5x, bring it down, times, reduce this, again,
2.
divide, reduce, will be 2. Once you do that, that's it, your fractions are gone and you have a much easier equation now. Much easier to solve. So what do we get here now? When we multiply, it will be
8
Like,
8x minus,
3 minus 3.
3.
okay,
10.
10x.
10x. So once you cancel your fractions, all these steps apply. So you apply all these again if you have parentheses, distribute, combine like terms, move, all that stuff. So what exactly do we need to do here now?
Combine the x's in the one side and the numbers in the other side.
That's right. So we're going to basically move the 10x to the other side. What happens to the 10x if we move it to the other side?
The sign change. We
That's right.
become
Negative 10.
-10x.
Negative.
That's right. This also moves. So 3, it's a negative number. Going to move it back here. The 8x minus 10x equals 3 on the other side. Negative 3 turns into positive 3. Now we can combine, add, subtract. That's
Negative 2x.
That's right. Negative 2x equals 3. One last step.
X equal 3 out of -2.
That's right. Basically, we need to cancel the negative 2. So we're going to divide it by itself.
Minus 2.
That's right, on
Minus-
both sides. That cancels. That cancels. The x is negative
3
3 over 2. Okay, so as you can see, it doesn't take that long to solve an equation with 3 fractions or more. By the way, the exact same thing applies if you have, let's say, 5 fractions or 6 or 7, same way. You may even skip one step here. You could skip this or maybe this. I know I write every step, but it doesn't mean they're out of 1, 2, 3, 4, 5. There are probably 3 steps here, but I like to write all the details. But you may skip some steps, for example. You don't have, maybe
Professor,
you don't
that's
have to
what I did.
rewrite it. Okay, yeah, possibly,
Uh,
but you don't have to rewrite it. So sometimes I rewrite the equation, so I'll leave this clean. I could have multiplied the right away instead of writing this line. I could have just said 12 by 3 is 4 times 2 is 8x, but you may skip a couple of steps, but
In the last step, Professor, if
Mhm.
I did the same way that I told you.
That's
last
fine.
week,
no, that's fine. I know
If
you
I
just want to
move-
move the negative.
Yes,
negative two.
because I get the same result.
Same answer, yeah. Same answer. Yeah, that's the way I learned how to do it too, though. But yeah, that's the way I used to do it too. But now I try to show every step so everybody can see. At the end of the day, the final answer should be the same regardless of the steps or the method. Okay, so when you have multiple fractions, again, remember these 3 steps. Don't worry about the little details here, all the steps. These are your main steps. The rest is just some math, multiply, add, but find LCD, multiply, and simplify, and you should get rid of all your fractions. Any questions about this last problem, everybody, before I give you another one?
All clear, Professor.
Okay, so by the way, you may have, for example, another term here, for example, just 3. For example, this, and 3. First, you want to make this a fraction, and then find the LCD for all of them. Just in case you have one number without a fraction, make it a fraction, then include that in the LCD. So you're going to find the LCD for all of these. In this case, we didn't have one, but it's fine. Give you probably one last example here, one last problem. So 2x minus 1 over maybe 4. And x plus 3 over 5, for example. So there's an equation here with 2 fractions only. There's a couple of ways, at least a couple of ways to do this. What do you think is the easiest way to use according to what all we've done?
X
So
X
far.
multiplication.
That's right, the cross multiplication. You can still do this
cross.
again. You can still find the LCD for 4 and 5, which is 20. You can times by 20, times by 20 on both sides, cancel. But whenever you have 2 fractions only, it's always probably convenient and faster to just cross multiply. Always do that. If you have only 2 fractions, don't worry about finding the LCD. Don't worry about this. This will skip you a couple of steps. It will skip you basically this step and this step. I think you jump right to this step here if you cross multiply. So, so cross multiply. Basically, like I said, multiply one way, so that's 4 the x plus 3, and multiply the other way. So this times this, or 5 times this. As you can see here, the fractions are gone, and we are basically at this step here. We are here, you just have to, once you cancel the fractions, if you cross multiply, the fractions cancel right away. So we're back to this, we're back to all these steps again. Okay, so the rest is simple. What is the next step?
Multiply 4.
That's right. Distribute. Distribute first, combine like terms.
Plus
Okay,
Yeah.
plus.
plus
12.
12.
That's right. And
10x
10x plus
minus
Minus
6.
minus.
minus 5, right?
Minus
We're
5.
multiplying. Okay. What else? So multiply. There's no like terms here, no like terms to combine on the other side. So
Move
what happens there?
the
4x
move
4x
the
minus 10x.
x.
That's right.
Yeah.
So move the x's to one side.
Yeah.
Numbers to the other, both at the same time. End up with 4x. What else? 4x and
negative 10.
Minus.
Minus 10.
okay, minus 10x. And
Minus 5. Minus 12.
that's right. So and the positive 12 becomes negative 12. Then combine
Minus 6x.
minus 6x equals negative.
Minus 17.
Minus 17.
That's right. Negative 17.
And
One
x
last
is
step.
17 over 6.
That's right. So the last step is to basically cancel this. So to cancel the negative 6. You're gonna
We
divide it.
also cancel the signs.
The sign will cancel out. Negative divide negative will turn into a positive. So these two cancel out. X is here. And if you have 2 minus, earlier I showed you that if you have 1 minus, you can put it here, you can put it in the middle, you can put it up. If you have 2 of them, they cancel out because negative divide negative is positive. Just like negative multiply negative is a positive. So both of those are gone. You get 17 over 6. And that's basically how you solve your equations. They're pretty simple. Just know your signs, okay? The signs and the properties we talked about last time. You need to know those basics. So in this class, college algebra, basically you're supposed to be very good with the signs, very good with the fractions already. The basics, okay? The decimals and stuff. You should be good with those basics, arithmetics. If you have troubles with those, make sure you review them because we will be using them in this class throughout the semester. Okay, what else? All right, any questions, everybody, about this last problem? Let me know if you have any questions about this one or anything else. Everybody, if you have anything, any questions about anything else we've done today, let me know.